guys. Today this is gonna be a decently long class. We're gonna do two-word problems to start up, and then we're gonna get into inequalities, which is pretty simple after you get the hang of it. So let's look at this. A patrol boat left Goderich and traveled for 45 kilometers along the coast of Lake Huron at a speed of s kilometers per hour. So the speed is, or to say the velocity, what is this? The velocity v is equal to s. Okay, s per hour. Now, let's look at what they want us to do in the first step. So, the first step, they want us to write an expression to represent the time taken. So, usually, these type of things where you have to deal with this, you use a formula from physics. V equals dt. You should have used this formula back in grade 10 in math as well, because it's a really common formula. Velocity is the distance traveled divided by time. And it's intuitively, it makes sense. So, whenever you have a formula, you just have to think about it intuitively. If it doesn't even make sense intuitively, like if the distance traveled equal to velocity divided by time, that is maybe not the correct one. So right now we want to find time. We want to write an expression for time. So we'll have to isolate t. So t, we'll multiply the left side by t, and then we'll divide the right side by v. So it's going to be equals to d to v. And distance traveled, we remember it was 45 kilometers. And now this velocity I wrote here, it was s per hour. And there you go. That was our answer for question number A. Let's move on to B. The boat returned to Goderich at a speed of 2s kilometers per hour. Write an expression that represents. Okay, so now we're still using t equals dv. But remember, our d is still 45 kilometers. Since we went and we came back, it's the same distance. We can't change the distance. However, our speed now is 2s per hour. So that is that. Let's erase this real quick. And then let's get on to C. Simplify the expression in. Okay. So instead of writing s per hour, I'm just gonna write s because we all know s is in kilometers per hour. So I want everybody to understand that. So our part A answer was 45 divided by s, and our part B was 45 divided by 2s. And now we have to add them together because this was T1, this is T2. Now we want the total time. It's gonna be T total. Okay, I shouldn't write it here. Plus T2. It's gonna equal to T total. So this is the equation. So now when we add them together, which is what we're gonna do right now, we're gonna have to multiply this side, multiply this by 2. So this is multiplied by 2. So this is going to give us 90 plus 45, which is 135 over 2s. Now, since 135 is not divisible by 2, this is the most simplified equation. If it wasn't able to be divided, then we would have gone farther. Okay, we actually needed the answer, which is, let me just erase everything. So the answer was 135 over 2s. Now, if s represents 10 kilometers an hour, we are going to go ahead and figure out how long we traveled. 135 over 2 times 10, which is equal to 20. So now 135 divided by 20, let me get a calculator. It's going to give you 6.75. 6.75 hours, otherwise known as 6 hours and 45 minutes. You can give it out in 6.75, or you can do 6 hours and 45 minutes. It depends on how you want. However, in this case, it didn't specify that you have to give it out in hours and minutes. So 6.75 hours would be a perfect answer. Now for 9, for the second example, two triangles have the same baseline, which is x. Okay, so let's go ahead and draw two triangles. X, this is also x. The height of one triangle is x plus 1. And the height of okay, so remember guys, this is the height. This is the height. these ones are not the height. These ones are not the height. Please, guys, remember. Oh, I can't draw it like that. I'll try my best. So this is the sides. These aren't the height. So only the one in the middle. This is a height. So this is x plus 1. And this is x plus 3. Now, the formula of a triangle, this area, which we should remember, is base times height over 2. So now they want the total area. So we will figure out the area for 1, and then we'll figure out the area for 2. So now let's go ahead and plug everything in. So the base is x times x plus 1 over 2. And then the second one, it's x times x plus 3 over 2. So now when we simplify this, this is going to be x squared plus x squared plus 3x all over 2. This is going to go ahead and give you 2x squared plus 4x over 2. And now we can take out a common factor of 2. So we have to remember we have to cross on both of these. So usually the teacher doesn't like you to do this. They want you to do factoring first, which is 2x squared plus 2x over 2. And then you cancel out, and then your final answer will be x squared plus 2x, which is the total area. So they want you to cancel it out like this because they will always specify you can only cancel with multiplication. But if you're confident, just do it right away. It doesn't really matter. As long as you're getting to the right answer with the correct amount of steps, you should be fine. Like most teachers do not really care that much. Okay, so now let's get into our today's main deal, inequality. I can't write that. So inequality, you would look at it. It will always have a bigger than, smaller than, or bigger or equal to, smaller or equal to. So it will for the question to even become an inequality, you will have to have at least one of these signs. If you don't have any one of these signs, you're not an inequality or just a random expression. So we'll go ahead and get to solving it. So honestly, there's nothing much different than solving an inequality to solving a regular equation. We will treat this or this or this or this. We'll treat that as an equal sign. So now we want to isolate for x. So how do we isolate for x? We will move the 2 on the other side. So 3x minus 2. For us to isolate the x, we have to plus 2 on this side. And then we also have to plus 2 on that side, which is 15. So 3x is smaller than 15. And now what do? We divide. So this side is gonna be divided by 3, that side is gonna be divided by 3. X is smaller than 5. And therefore, we have solved the inequality. And obviously, before this, I want to talk about something called simplifying inequality. So for example, if I have 4x is smaller than 8, we can divide both sides by 4, and we directly get the answer, which is what we did right there on the question number 1. But overall, you just have to remember, treat it like an equal sign. It's nothing different. And then if you want to check, so our answer was x have to be smaller than 5. So why don't we plug a random number, let's say 3. So now on the left side, we'll get 9 minus 2, which is 7, smaller than 13, which this checks out because the left side is smaller than the right side. Now, solving and graphing. So many people don't understand what graphing means in this case. Really, it's not the entire thing where you have to do a Cartesian plane and graph it and be like, oh, this side can't have any x. That's not it. So let's get to solving first. So first, when we have a bracket here, we have to go ahead and expand it because we can't just deal with the bracket. Okay, sometimes we can. In this case, we can, but most times you will want to go to expand it. So whenever we look at an expression, we'll always get rid of the negative -1 or plus minus. We'll get rid of that first. That's because these ones are the ones where it doesn't really matter, so you can just always move it to the other side, which is 8. And now, direct division, so 3 minus x is going to be smaller or greater than 4. And now, to get the 3 on the other side, we'll have to minus 3. So negative x is smaller, greater than we have a negative sign here. That is not good. So what do we do here? Is that we're going to, why don't we divide both sides by -1? So now divide by -1, x, and now this side is -1. However, whenever we divide by a negative term, when you multiply or divide by a negative term, you always have to reverse the symbol. So instead of -x being bigger or smaller, bigger or equal to 1, we now reverse the term to become x must be smaller or equal to -1. So now let's just try a random term. Let's say x was equal to, um, let's say x was equal to 0. On the left, you would have had 6 minus 1, which was, sorry, 0. You would have had, sorry, yeah. So you would have had a number that was bigger or equal to 7, right? And then, yeah, that's pretty much it. That was the answer. So let's go ahead and draw a number line. So let's start the graph part. So graphing part, we're actually using a number line. So let's say this number here, we had -1. So now we have to introduce ourselves notations. So on the number line, when I have an open circle versus a closed circle. So a closed circle is for those that includes -1. So look, in our case, x have to be smaller or equal to -1 for the inequality to work. However, since it's smaller or equal to -1. This means that equal to means -1 is still included in our sequence, in our entire series of numbers. So we will draw a closed dot on -1 to showcase that -1 is part of this. But when we have a smaller than, this is when -1 is excluded. So this is excluded, exclude, and this is included. That's the difference between the two. And then by graphing, we're actually just drawing our possible values of x. And I just wanted to talk about my example earlier. The textbook used 0 to show that the inequality would fail, because at 0, it would be 6 bigger or equal to 7, which is not true. So this inequality only works when we have an x value less than -1, less or equal to. So let's say -2. So we will have 3, and 3 minus -2 will give us 3 plus 2 minus 1. This is going to give us not 10 minus 1, bigger or greater than 7. That's going to give 9, bigger or greater than 7. So textbook give us 0 to prove that the inequality did not work. And I was I was done. I didn't know what was going on. So now let's start with one including fractions. So whenever, just like you would do to a polynomial or a rational expression, whenever you have a fraction, you would usually want to get rid of it. So let's say if I have, let's say 3 over 4. How do we get rid of the fraction? We'll 3 over 4, let's say 1 over 2. How do we get rid of it? We'll multiply by 4. So this is divide by 4. So after we divide, we just multiply by 4. This one we also multiply by 4. So on the left, we'll have 3. However, on the right, we will have, this is definitely not true, by the way. We're just trying to simplify it. So on the right, we multiply by 4, but we realize, so this is going to become 4 over 2, which is 2. And this is obviously false, so just so you guys know. So we'll do pretty much the same to an inequality. Is that we're going to multiply by 4 in this case. So we'll have 3x. So we'll have 3x multiplied by 4 divided by 4. So the 4 cancels out now. So we didn't have to write it. I just have to show you guys. Plus 4x over 2. And the 4 divided by 2 is going to give us 2x. It's going to be bigger than 5 times 4, which is 20. Remember, when you're multiplying one side, you have to multiply the other side, because really, you have to do this. There's no excuse around. Now, we collect the like terms. 5x is bigger than 20. Now we divide by 5, and then x is bigger than 4. So finally, here is our answer. For the inequality to work, we have to have an x value greater than 4. And then let's talk about our second last example. Yep. So we're gonna solve one including decimals. So just like fractions, decimals is not really the same. It's not different at all. So usually, I would love to solve for decimals a lot more, simply because it's just a lot easier. We can directly input it. So let's go ahead and do this. So let's simplify it. First, we gotta expand the bracket. So this is this part where we have to do it. So that's gonna give us 2, 0.5 times 4 minus 0.2x times 6. 0.2x is gonna be 1.2. 0.5x plus 0.5 minus 2.8. Now, what we do is that we're gonna get the x's to be all on one side and get the okay. You know what? Why don't we collect the like terms first? Just because I want to do an extra step for you, because I feel like if I skip too much steps, people won't get catch on, simply because this is not good handwriting. So we collected these like terms. We simplified it to this 0.3x plus 0.8. On the right side, we will have 0.5x minus 2.3. And now we will leave the x's all to one side and get the real numbers to one side. So let's do negative 0.2x. Okay, so I actually don't. So that was the textbook step. However, I don't actually like that step. So why don't we move the 0.3x to this side? So 0, we have a positive, so we will minus a 0.3x. So that gives us 0.2x on the right side. That was 2.3. And bigger than, we will add a 2.3 on this side. So 0.8 plus 2.3, that's going to give us 3.1, I believe. Am I right? Yes, I am right. So 3.1. And now we just do simple division, where we're dividing both sides by 0.2. And 31 divided by 0.2, that's going to give you 3.1 divided by 0.2. That's going to give you 15.5, which is smaller or equal to x. And therefore, any value that any value of x that is greater or equal to 15.5, this inequality will have a solution. Now, whenever we're told to solve it, people usually have a blunted idea of what does it mean to actually solve an inequality. It means that this inequality will be true when x is greater or equal to or smaller or equal to this certain value. So we're actually finding the real solutions. Sometimes there is no real solutions, and that is actually an possible answer. And I have done that on tests just to confuse people. Now let's do a word problem. So I love word problems. Volunteers from a hiking association are selling hiking staffs as a fundraiser. The cost of making the staffs is a fixed overhead of $2,000 plus 10 per staff. Each staff is sold for $30. What numbers of staff must be sold for the revenue to exceed the cost? Okay, we are gonna build an equation. So let's do the cost. What is the cost? The cost is gonna be always $2,000. This is always gonna be holding true. Plus 10, and then let's you have to write a less statement, guys. Let the number of staff be x or something. Let's just write that. Let the number of, and then plus 10x. So basically $10 per staff, and then the revenue is gonna be 30x. So now we have to make sure that revenue exceeds cost. So 30x is bigger than 2,000 plus 10x. What do? Move the 10x over to the left. So that's going to be 20x bigger than 2,000. Divided by 20, x is bigger than 20. Oh, wait, sorry. What am I doing? X bigger than 100. Right? Yeah. Okay, so for our revenue you will write your concluding statement. Therefore, for revenue R to bigger than cost, we need x have to be bigger than 100. And then that is pretty much it. Yep, that is all the example that I want to show you. Now let's get on to the practice part. So one thing I want to tell you is that all of these ones can be solved using decimals. So if you know the website, you know the website. It's decimals. I will make like an entire session on teaching you how to use decimals, because decimals is a really powerful tool. It can solve inequalities, solve pretty much everything. I can solve up to calculus integrals, and it's just literally the best math software you will ever see. And it can graph it out, so sometimes you can see the answer directly. Now let's just move on to these easy stuff. So I will do a question real quick, and then I'll do 3h because that's some expanding to do. So y is smaller than 2. That's the first answer. And then let's just do 3h. So first we'll observe if we need to expand. And then we realize, oh look, there's x on both sides. We have to expand it. So if there is not, like, if there's only one x on if this x is only one side, you usually do not have to expand it because we can do some math. However, if it's on both sides, can get over it. So we have 6s because we moved that over. So this is -5, and that side is 5. So -5, and that is 5. So plus 5 x smaller than 10 over 6 being 5 over 3. Right? I did nothing wrong, right? 2x minus 4 minus 1, 4x, 4 minus 4x plus 4, 6x minus 5 plus 5, 10. Yep, I did nothing wrong. So our answer will be this. So don't doubt yourself if you have a fraction as your answer, because that is possible most of the times. And yeah, this sums up our entire unit 1. So I will go through the McGraw-Hills Ryerson Unit 1 practice test with you guys, just so we can get a hold of this. And then I will hopefully release my test here if the Academy allows me to do that. But that's it.